So we are starting with square and square root. Exercise 3.1. So here's the question. Which of the following natural numbers are perfect squares? Give reasons in support of your answer. So we have first question, 729. So in order to give the reason, we have to go for prime factorization. So write prime factorization over here. Find the prime factorization of 729. I start with solution. Square root of 729 should be, and you will find the factor. Now 7 plus 2 is 9, 9 plus 9 is 18. So this goes in 3. So we have 3 2s are 6, 1 carry, 4, 3. Again, you have 2 plus 4, 6, 6 plus 3, 9. So it goes in again 3, 81. And 81 goes in 3. So we got 27. Then this is 3 9s are, then 3 3s and 3 1s are. Now go for pairing it. So check whether it's pair. So yeah. So we have 3 into 3 into 3 into 3, 3. Since now you have to write the reason. Since all factors of 729 are in pairs, therefore 729 is a perfect square. Okay, let's go to the next one. So I'm doing the second one. Rest you can do by yourself. Second question, 5 4 8 8. So now again we have prime factorization. Let's solution over here. So we have 5 4 8 8. Go for 2. Now this could be a long method, but yeah, this is the method you have to follow. Again 2 1 3 7 2. Again 2. We got 6 8, 1 carry 6. We have 2, we have 3 4 3. Now 3 4 3 does not go in 2, neither in 3. So try 7, because we know somehow 7 4s are 28. We got 63. 9s are 7 7 1. Now if you focus on this one, the factors are of 5 4 8 8 are, we have 2 into 2 into 2 into 2 into 7 into 7 into 7. Now you can understand this. Underline the pairs. Now you can understand, you can box this. Since all the pairs, all the factors of 5 4 8 8 are not in pair. In this case, we are talking about 7. So I'm writing in case, in this case, 7. So therefore 5 4 8 8 is not a perfect square. That's it. So you can do the rest of the two sums by yourself. This will be the two type of question that can come in this particular topic. Let's go to the next one. Show that. No. Question number 2, first one. So let's just read. Show that each of the following number is a perfect square. Also find the number whose square is the given number. So you have to find the square root as well. So you have to do the same method, but in this method, you have to find the number. So we have 1 2 9 6. Let's go for prime factorization. So 1 2 9 6. So we have 2 6 4, and then we have 8, and again we have 2 3 2 4, again 2 1 6 2, again 2, we got 81, and from here you can go for 3 27, 3 9s are 27, 3 3s are 9, and 3 1s are 3. So we have to find square root of 1 2 9. Now this is the thing you have to note when you're finding the square root of this particular number. Okay, so we have 2 into 2 into 2, and then we have 3 into 3 into 3 into 3. Now you can underline the pairs. Now for the first question, they're asking whether it is a perfect square. So since you have to write, since all factors of 1 2 9 6 are in pairs. So therefore 1296 is a perfect square. Okay. Whereas if you have to find the root, you have to just take it. Therefore the square root of 1296 is, take 1 out, we have 2. From this you take 1, this 3 and 3. So we have 2 2s are 4, 4 3s are 12, 12 3s are 36. And that's it. That is the number. The square root of 1296 is 36, or the square of 36 is 1296. That's it. Let's go to the next one. Let me just choose the last one, fourth. We have 3969. Again, go the same way, prime factorization. We got 3969. You can start with 3. 3 1 3 2 3. Then we have again check 4 6. Yeah, again 3. 3 4s are 1. And then we know that 441. We have 1 4 7 147. Again, if you see, we have 5 plus 7 12. So this also goes in 3. 3 4s are 12, 27 9. And then we know 7 7 7 1. So we understand the factors are 3 into 3 into 3 into 3 into 7 into 7. Now you can underline the pair. Now since factors of 3969, please remember this line is very important. Are in pair. Therefore 3969 is a perfect square. This you will get 1 mark, and then we have to find the square root. We have 3969, and that would be, take the square root of the whole thing, 3 into 3 into 3 into 3 into 7 into 7. Then you just take the numbers out. We have 3 into 3 into 7. So 7 3s are 21, 21 3s are 63. So 63 is your answer. I hope you got it. Now, very important, this part, multiplied and divide. So we have question number 3. Find the smallest natural number by which 1008 should be multiplied to make it a perfect square. So let's understand. We have the number 1008. Remember, we use prime factorization in order to, in this two type, we have to multiply a number and divide by a number whenever you're finding the perfect square. Remember, not for addition and subtraction, we don't use prime factorization, we use division method. Okay, so let's go for this one. Solution. We have, just write prime factorization. Make sure you're not writing prime factorization in the rough column. This, you have to show the prime factorization in your sum. So we have 1008. Let's go for 2. We have 5s, then there is a 0, take a 0, and then go for 8, and which is 4. Then we have 2, 2 2s are 4, 1 carry, 5, then 2. Then again we got 2, 1, 2, 6, then again 2, we got 63, and now this will be 3, 21, this will be 3, 7, and then we have 7 alone. Now the factors are, first of all, we go for factors are, write all. Now, in order you don't miss this part, make sure you do this so that you don't miss any factor. So what I do is actually I make them a pair so that you remember there are how many 2s or how many 3s are there. Many times you miss the number. So you underline the pair, you box the non-pair number. So we understand that in order to multiply, we are missing 1 7 from this pair. Okay? So we multiply 7 to make 1008 a perfect square. Make sure you're not skipping this line. Okay, so we multiply 7 to make 1008 a perfect square. That's it. So let's go for the fourth question. Now in this one, find the smallest natural number by which 5808 should be divided to make it a perfect square. Also find the number whose square is the resulting number. That means you have to find in the factor, divide by something which is not a pair, and then ultimately find the square root of the number of that perfect square. Okay, I hope that makes sense. So we have 5. So we have 5808. So let's go for the prime factorization. So I'm writing it here. I hope that is okay. We have 5808. Let's go for 22904. Again, we have 21452. Again, we go to 7 2 6. Then you go 2 again, 3 6 3. Now this will be with 3 3 1 2 1, and we know that 1 to 1 is 11 square. So it's better that you remember certain numbers, the square of certain numbers. Okay, so the factors are, so let's understand. We have factors are solution 2 into, so like I do, and this one we have 2 11 into 11 into 3. So I'm underlining the pair, I'm boxing the unpaired thing. Since this is an extra, remember this is extra, so you have to divide by this number. So to make it a perfect square, it should be divided by 3. Now they are not asking you to find the exact square. They're asking you to find the square root of this new perfect square number. So what do we have? So after you divide the 3, you don't have this particular 3. So now we have this number. So if you take the square root of this part, we have 2 into 2 into 2 into 2 into 11 into 11. So that would be 2 into 2 into 11, which is 44. That's your answer, by the way. Okay, thank you.